Thanks, Peter. Good morning, everyone. So this is me. I'm a developer and I'm a civil servant working for the Government Digital Service. And this talk's it's a success story for Python, really, with a bit of a technical interlude about halfway through. So hopefully something for everyone to an extent. If I can work out how to get the thing. Okay, so a very quick show of hands. Who's ever heard of the Government Digital Service, GDS? Oh, more than I thought, maybe. Okay, some people don't. So I'll give a very quick overview, just so to give you the context of the work that we've been doing. It's part of the Cabinet Office. It leads digital transformation in government as a whole. So it's working with lots of the other departments to help them deliver their digital projects. We're working in small teams, agile teams of developers, designers, content creators. The project I work on, we've got very cross-functional. We've also got legal people and procurement people, and we all work together. So the main thing people probably know about GDS is, and the first project they built was gov.uk, the website. So GDS launched in April 2011. The first big project was to get the websites from 24 departments all under one banner of gov.uk. Before that, all the departments ran their own websites. They all looked different. If you were a citizen and you wanted to interact with government, you had to know which part of government did the particular thing that you wanted to do. And the philosophy behind gov.uk is that people don't really care what the structure of government is. They just want to go somewhere and do the thing that they want to do. So there should be one place where people can go to access government services. So that was the first big project. 24 departments brought on for the launch, and since then there's about 300 or so other related agencies and government bodies now all have their websites that live on gov.uk. This is mostly built in Ruby on Rails, and I'm not going to mention it ever again. But at GDS, we also do lots of other projects. There's transformational projects out with the departments, building transactional services. I did a quick check of our GitHub repositories before I came. There's 63 repositories of Python code. Most of those are public, and you can see them on GitHub. A few of them are private, I guess, if they've got secret stuff in, or people just, but in general, we code in the open. I wouldn't say what we produce is open source, but we code in the open, and anyone can go and have a look at what we're doing. So these are just some of the projects using Python. There's GovUK Notify, which is a service to be used by other government services to send SMS, email, and even paper letters. So they provide an API that other services can hook into, so that we just have one thing that's doing all of the sending of stuff, rather than having 30 different services all using their own SMS providers and having to integrate with those sorts of things. Data.gov.uk is about opening up data and publishing government data. Anyone can go and have a look at it and do what they want with that. And Digital Marketplace is the project I've been working on for the last 2 years, and that the rest of the talk is about. So Digital Marketplace looks like this. The reason it exists isn't so much a citizen-facing service, but if government wants to buy things, they can't just go down the shop and buy whatever they want, or if they want a service or they want to hire someone to do something, there are rules about how they do it. It has to be a fair, open, and transparent process. And Digital Marketplace is where government buyers can come to buy cloud-based services, and also to hire people. So one of the things we have, there's a thing called the GCloud Framework, which is now in its 8th iteration. There's over £1 billion of taxpayers' money has been spent through that framework on cloud services since it launched in 2012. So that's our money being spent on hope. The idea of the marketplace is that we're trying to get away from these huge government IT projects that then fail, cost millions of pounds, and don't work. The idea is government should be able to move much more quickly and buy things in smaller chunks and not commit to these huge contracts. And the digital marketplace is where they can do that, and the GCloud Framework is one of the ways of doing it. So if I've talked about framework already, I'm going to have to explain it a bit just because most of the headings in this talk are about different frameworks. So a framework is an agreement between government and suppliers. So suppliers who want to sell their services to government apply to be on a framework, and then if it's agreed that they can be on the framework, they're kind of pre-approved to supply stuff to government. And this saves time and money because running a full open tender can be really time consuming. So if you're in a department, you want to buy something, if you have to go out to the whole market of Europe and advertise, this is the thing I want to buy, how much are you going to charge me to do it, that can be a very long and expensive process. Having these frameworks where you've got pre-approved suppliers mean they still have to run a fair and open process, but it cuts out a bit of the overhead. And it also ensures compliance with the EU procurement regulations because government buyers are very nervous generally about getting sued by suppliers if there's any perception that the process they've been through isn't fair or compliant with the regulations, then suppliers can sue. That would cost us money as the taxpayers, and so people want to avoid that. So yeah, the GCloud framework I've already mentioned is purely about buying cloud-based services. Okay, so onto the actual title of the talk, Transforming the Digital Marketplace from Portal to Platform. So it's going to be a bit of a history of this website, this service. So the first 5 iterations, so I should explain, suppliers can you can't apply to go into a framework at any point. There's a limited window of time where you can say, okay, I want to supply these things, and then that cuts off, and then it runs for a while. So then you have to open applications again for another period. So that's why you have these iterations. So the first 5 before my time, and mostly before GDS had taken over the digital marketplace. At that point, if you wanted to supply stuff to government, then there were 2 separate systems you had to interact with. They're run by the Crown Commercial Service, who are in charge of helping government people buy stuff. There was an e-sourcing portal where the supplier gave all their details, like what's your company called, who's the contact, are you insolvent, and there's a whole bunch of other questions that they get asked. And then there's a separate system altogether called the Service Submission Portal, where they say, okay, these are all the services that I want to supply to government. And then the digital marketplace is a third system again, which would happen. So after those 2 things have been filled in, if the suppliers are accepted onto framework, then they get their services get put into a searchable catalogue on the digital marketplace. It was built using the Grails framework. So this is when I kind of started on it, I'd never seen Grails before. It's written in Groovy, which runs on the JVM, so it meant you could write Java if you wanted, which was fine for me because I was a Java developer at that point. And this is a point where I started working as just GCloud 8 was coming up to open, and the first thing I was told was, okay, what we need to do is bring the service submission portal, which is one of those external things that CCS ran, into the digital marketplace, and we've got to ship it in 6 weeks because that's the deadline we've got. And so we had a bit of a play around, started learning how this Grails application worked. We had 2 contractors there at the time, but who were rolling off, and they built the whole thing. It turned out it was slow, it was difficult to work on, it was pretty much impenetrable. It took over half an hour just to run the tests, and we very quickly decided that there was no way we were going to be able to ship this new feature in 6 weeks. So we built because we had Java developers, we decided to use Java. We had no dedicated WebOps people at all, and so the developers were going to have to run the whole thing, so we ran it on the Google App Engine. And we made it so it looked like the existing digital marketplace site, but it was a completely separate app, and we designed it to throw away. It was going to be turned on for 45 days. It would collect the data from about all the services, and then we'd ship that data out and turn the whole system off. And we did it, and we shipped it in 6 weeks, and it all worked, which was good. But then, this is kind of the story of my life, is we're driven by these deadlines, because there's always another framework that's got to open. Okay, 9 months later, we've got to ship GCloud 7. And For GCloud 7, we decided we're not having any more portals at all. And the first thing we did was kill the Grails app. And this is a picture of Python crushing a Grail with fire, which I've got a sticker of on my laptop, which is our designer kindly designed for us when we finally managed to turn off the Grails app, and that was a very good thing. The way we did it was we started by buying a book. I'd never written any Python before. We had one dev on the team who had, and he said he thought Flask was good. So we bought a book, we read the book, or most of the book, and we replaced the one Grails app with 5 new apps, Flask apps, and this is our setup. So our database is, main database is a Postgres database. We have a data API application that is Flask. It talks JSON to all of our front-end applications. That's the only thing that has any direct access to the database, though. We've got a searchable catalogue, and for that we run an Elasticsearch cluster, which has a search API that talks, is the only thing that talks to Elasticsearch. The data API talks to the search API because if it needs to update any records in the search index, it can push stuff across. But other than that, the front-end applications we split out by the types of user we had. So admin users might need to go in, edit people's details, edit services, whatever, see what's been going on. Suppliers, they could log in order to submit their services because we brought this service submission stuff into the application. And buyers had a different application because their main thing they wanted to do was to find services to buy. So they kind of basically have this searchable catalogue. And that's what we did. So we'd already replaced the service submission stuff. We also decided to replace the sourcing portal. So suppliers finally had one place where suppliers could come. They could apply to supply their services, and it was the same place that buyers came to try and buy stuff, and finally kind of got all of those things in one place. And we kind of believed, and the idea was that the system would be a platform for frameworks, so we didn't want to be having to rebuild the whole system every time there's a new framework coming up. You know, we've done this Grails thing to start with, then we've done this Java thing for GCloud 6, we're doing this new thing for GCloud 7. What you want to do is get away from building new things. And this work took about 9 months altogether. This is the psychedelic versions of the Python crushing the Grails that also got made at the time. I didn't like them as much as the other stickers, though. And this is a kind of technical aside about how we actually make it a platform for frameworks rather than a thing that's completely specific. So in technical terms, the marketplace is this searchable catalogue of cloud services for buyers and an awful lot of web forms. Everything else is just forms. So, for example, a supplier declaration, which is the thing they used to fill in on their e-sourcing portal, is about 60 questions they have to answer about their company in order to get approved to be on a framework or not. And then if they want to describe a service they want to provide, there's about 90 questions per service, and some suppliers have many services that they want to get onto the framework. So this is a lot of form filling that people have to do. And buyers, if they're building up a set of requirements of what they want to buy or someone that they want to hire, there's about 30 questions. So it's all forms. And these questions change. The content's written and iterated the same time as the application code. We don't get handed a set of questions and say, okay, this is exactly what it's going to look like. Can you make that work? People are still working on that stuff as we go. And because we don't want developers to be involved every time someone wants to change a word or change a capitalization or add some bullet points or add a new question, we have a completely separate content repository, which is made up of YAML files, and the content designers who are designing these frameworks and questions can go in and edit that stuff. And so an example file might be this. So this is a question about if you want to supply a service, what's your service called? So the question is service name. You see the type is text, and we have and text will give you a text box. We have all the other kind of good web formy types that could be checkboxes, radio buttons. And we also have the validation messages that should be shown if someone's made a mistake when they do it. So a YAML file like this gets rendered by the front-end app into a form that looks something like that and pulls all the data in. And so we have one file per question. We also have these manifest files that define the ordering and structure of the content and how the question should go. So this is a file, also YAML, that defines two sections. The first section is about what's your service called, service name. It has one question, service name. The second one is a section about features and benefits of your service, and there's two questions in this section that would both be displayed on the same page about service features and service benefits. So the manifest is essentially a tree structure that has made up of sections. Each section is made up of a number of questions. Then we have a thing called a multi-question as well, because generally we tend to show one question per page, but some questions, like an address, you might want 3 fields for an address, but it's all one question, so that gets split out as a multi-question. And within this content, have different manifests for showing the service listings, so that's when buyers are coming to view the stuff. There's a different manifest for actually showing the questions, what order should people answer the questions in, and also for the question for the declaration and the question for the services, and also the search filters on the buyer front end are also defined by a manifest file in the content. And our API uses JSON schema to validate the data that's sent into it. And rather than us handcrafting these schemas to do the validation, we can automatically generate them from the content. So content designers go in, they write their questions, they build up these YAML files, and then we have a script that will run and read over those files. And because the validation messages and the validation rules are in the content, we can automatically generate the things to validate them. So the generated schema looks something like this, and this is a rule that says that the service name can be at most 100 characters, and it needs to have at least 1 character. So in the front end, if you try and save and continue without entering anything in the box, you get a validation error, and that's automatically generated from the content. We've not had to write any validation rules into the app at all. We just have a JSON schema that we get straight out from the structure of our content. So this is kind of how it works. So we've got the content over in the YAML files. They're pulled into the front end, so the front end knows what questions to show. But also the JSON schema is also created by the same content, and they get stored in the API, and the API uses those to check things. So it's kind of, it's quite neat, and it saves us writing custom validations in the front end. And the idea is that as long as so this is kind of making it a platform, because whatever content you plug in, then the front end and the API should be able to know how to deal with it without hard coding anything about those questions or those frameworks into the front end apps or the API itself. So Digital Outcomes and Specialists was a new framework that came along. Is anyone here on the Digital Outcomes and Specialists framework, out of interest? A couple of people, good stuff. And this was the first, this is a framework for hiring people more than for like cloud services which are commodities. So, and it was the first ever non-GCloud framework on the marketplace. And we thought, right, we've got this platform now, this is going to be a doddle. We'll just write the questions and it'll all fall out. But it didn't quite turn out like that. It turned out when we tried to do this, because it's a very different framework, it had different types of validations, it had different kind of categories. It forced us to unpick an awful lot of GCloud-specific logic from the application. So we thought we'd made a platform for frameworks, but then when you try to do something completely new, it turns out actually there was a lot of things that we'd assumed that we probably shouldn't have done in the application. So that took us about another 3 months to unpick all of that stuff and get this new, completely new type of framework up and running and driven by the content. And then, because that took longer than we thought, we're straight into, okay, with GCloud 8, it's the next thing. So have we finally got a platform? And it feels like we're winning a bit. So GCloud 8 opened for suppliers on May earlier this year, and that just took 2 of us less than 2 weeks to prepare and roll out. It was probably really only about a week's work. That was to get all the questions, to ship it through to all our environments, fix a couple of bugs that had turned out. And so comparing that to 9 months to get the GCloud 7 stuff out, another 3 months for the Digital Outcomes and Specialists, this really feels like we're kind of winning. And a platform should be something that's reusable. And so recently, we've been working with the Australian Digital Transformation Office, who to help them build their own digital marketplace. And they've done that by forking our code and just reskinning it and running their own marketplace themselves, which kind of feels like quite an exciting thing to have someone take what you've been working on and actually port it to the other side of the world for a different government. And this is what their marketplace looks like. And if you're paying attention earlier, you'll notice it looks very, very similar to our own digital marketplace. So that felt like another really good thing. So they've just, they forked our code, and they're running Flask and Python and just to spin up theirs. And they've done that in less than 2 months, I think it's taken them to get their own version of the marketplace up and running. So coming soon, we've got Digital Outcomes and Specialist 2. If any of you are interested in contracting for government at all, you might want to look at that and get yourselves on there, because it should be a good route to getting work with government departments. And there's also GCloud 9, which is going to be a complete shake-up and very different from GCloud 8 probably. So again, we're going to see how robust the platform is and if we need to build a whole bunch of new stuff or not, but hopefully not. And yeah, I'll take some questions now if anyone's got any. We're also here, and we've got a stand outside, so come and talk to us over the weekend or later today if you like. Thanks.
Thank you, Kevin.
Cheers.
Can I ask a question?
Yeah, sure.
I think also we're competing with the queue for the microbits.
Yeah. Don't remind them.
I'm sorry. Is Python still the right choice in retrospect?
Yes, I think it is. I mean, it's been a dream to work with. That was the first Python I'd ever done. I'd never seen it before. We managed to pick it up, build something that seems robust. We don't have any problems with it particularly. I think it's right. Yeah. Well, I mean, it certainly works for us. It's not the only option, but I certainly wouldn't want to start building it again from scratch. We kind of did it to last, hopefully.
Thank you. Question from Emmanuel.
Hello. So you mentioned that you have some YAML files that are used both by the backend and the frontend to generate forms and validate data structure. Yeah. I would suppose that on the backend you are using something like SQL Alchemy or something like that, which is already a data structure. So have you thought of generating those YAML files from the data structure and use them on the frontend instead of going the other way around? And if you have, why did you choose to go from the YAML files to validate the data structure in the backend and not the other way around?
I think the point of the YAML files is that people who aren't developers can go in and change things and make new stuff. And so I'm not quite sure how we would do it the other way around, because that stuff doesn't live in our data anywhere at all. The files are the primary source of it. I'm not, the point is that anyone can go in and change it, and then the front ends will kind of automatically be able to understand what the new stuff is and understand how to validate it. Sorry, sorry, if you wanted to clarify the question, I might be able to answer that.
That answers my question.
Okay,
so
great.
That other people can modify the data structure.
That's essentially the point of it. So that people who aren't developers can change things. Yeah.
Okay. So can we say thank you to Kevin again?
Cheers.